Welcome all. In this session, I'll discuss why the temperature is remaining constant during phase change. So, before I discuss that part, we need to understand what exactly is internal energy of the system. So, I'll throw a light and I'll give you a complete picture of internal energy. So, internal energy comprises of what components, and which component of internal energy is responsible for increase in temperature, and which component is responsible for the phase change. So, I'll take around 20-25 minutes and I'll try my level best to explain it in a clear manner. Okay, if you see water, it exists in three different phases. The same matter is existing in different phases, that is solids, ice, liquid, water, and steam, that is vapor state or gaseous state. Let's see the reason behind this. So there is one beautiful sentence. The microscopic behavior of particle describes the macroscopic behavior of material. I know it is a very simple statement, but it has a huge meaning. The microscopic behavior of particles, that is, the molecular behavior, describes the macroscopic, it gives the total behavior of the system. So that's why let us focus on the microscopic behavior. Chalo. My dear students, I'll give you a simple example. You take water, ठीक है sir. It is stationary, no problem. Macroscopically, in a gross manner, it is not moving or flowing. But if you look from the microscopic point of view, the molecules are in continuous random motion. So when they are in motion, definitely there is some energy associated with molecules. First, let us understand what are the different forms of energy associated with molecules. Then we'll come to this topic of phase change and kinetic energy, all those things. Okay. Now, my dear students, the molecules are in continuous translation. So it has a translational kinetic energy. The molecules are in rotation. So it has a rotational kinetic energy, which is half I omega square. And it also has vibrational energy. So if you see the total kinetic energy of molecules, it has a translational kinetic energy, rotational kinetic energy, and vibrational kinetic energy. So if I write the kinetic energy of molecules, so therefore it will be translational kinetic energy, rotational kinetic energy, and vibrational kinetic energy. This is the total kinetic energy of the system. Can I say this is the only energy available with molecules? The answer is no. My dear students, I'll give you a simple example. Let's understand. Let's take a water molecule. So there is one atom of oxygen bonded with two hydrogen atoms. So let us assume this to be oxygen atom and this to be color change karenge sir. Let me change the color. Okay, एक second please. These are hydrogen atoms. So this is H2. This is H2O. ठीक है sir. Now oxygen has affinity for electrons. It has electron affinity. So it tries to pull electrons or take electrons. So these two, hydrogen and oxygen, so they share electrons. It means actually इसके electrons ये थोड़ा share करेगा. So when इसके electrons ये थोड़ा share करेगा because it is the property of oxygen. So when oxygen is taking or sharing hydrogen electrons, so if you see the net polarity, so actually those electrons belong to hydrogen, but this is sharing, so it takes negative charge because it is taking extra. So it is electron affinity, it has electron affinity, so it is sharing with this, it is sharing with this. So actually they belong to hydrogen, but those electrons are being shared with this. So it will, as it is having more electrons, so therefore it will assume negative charge, and it is its own electrons are shared with this, so it will have a positive charge. Okay. Now this is clear, sirs. Now the same situation can be shown like this, like this. Yes. So this is oxygen, so negative, hydrogen, positive, positive. Observe here. Now, if you see this is one molecule. Now, क्या हो रहा है? It is positive, it is negative. There are attractive forces. This is one molecule, this is another molecule. Negative, positive. And this is known as intermolecular forces. Intermolecular forces. From now onwards, these intermolecular forces or bonding energy, I call it as potential energy. Kindly do not get confused with the word potential energy with the gravitational potential energy, which changes with the height. So this, whenever I talk molecular potential energy, it is the intermolecular forces or bonding energy. That's it. It has nothing to do with gravitational potential energy. ठीक है सर. So therefore, molecules also possess the potential energy, that is interatomic forces. So therefore, I need to add this also. To this, I add potential energy. Please note down that this potential energy is representing the bond energy or intermolecular forces. So if I talk about the total energy of molecules, translational kinetic energy, rotational kinetic energy, vibrational kinetic energy, plus intermolecular forces, that is bonding energy, which we call it as potential energy. So this total energy put together, you call it as internal energy, which I designate with U. Let's see what exactly is this. For example, I have water. Let us take a stationary system. It is at some height. Now, simply without disturbing this, I'll take it to the different height. So originally it was here. Now I'll take it to this height. Does this alter the internal energy of the system? The answer is no. The reason is the gravitational potential energy is increasing. This gravitational potential energy has nothing to do with internal energy, because the internal energy is a microscopic form. It is associated with molecules. This gravitational potential energy is the gross or macroscopic. So when without disturbing, if I lift it, I am not changing the bond energy. I am not changing the intermolecular forces. Therefore, neither I am increasing the velocity of molecules by supplying heat. ऐसा कुछ नहीं कर रहा sir. So therefore, when the water is here and when the water is lifted to this without disturbing, without causing the motion, the internal energy is not changing. So of course the gravitational potential energy is increasing. Please do not get confused with gravitational potential energy and molecular potential energy. This molecular potential energy is associated with intermolecular forces. Got it, sirs? Now, so I can say that internal energy has nothing to do with external situations. What do you mean by external situations? Whether you keep it here or here, it has nothing to do. It depends on the actually what is happening internally with molecules. That is our internal energy. So now, my dear students, I'll ask you to conduct one experiment. What is that experiment? Please, agar possible hai to karna. I would have conducted now in class itself, but actually I purchased one thermometer, but I am unable to find that thermometer. When I conducted like an experiment on wet bulb temperature, I purchased one thermometer, but it is somehow missing. But anyway, आपको ये करना है. Clinical thermometer से नहीं होगा सर ये, because now what you do is you take a thermometer and measure the temperature of this. Let us say it is about some 26, 27, whatever it may be. Now you just stir it. You just stir it. मतलब एक दो मिनट उसको घुमाओ. Stir it. Now you see the temperature. You observe a slight rise in temperature. अभी आपको क्या करना है? Same water you put it in mixer and rotate it, grind करो, sorry, उसको पूरा mix करो सर. मतलब you continuously rotate it for 1.5 to 2 minutes and measure the temperature. And you'll see an increase of 6 to 7 degree. तो क्या यहां पे एक फीलिंग मिल गया? When I am increasing the motion of molecules, the temperature is increasing. अच्छा, okay. Now let's see in detail now. जब हम टेम्परेचर बढ़ा रहा है, प्लीज नोट ऑन दैट. सो फ्रॉम दिस एक्सपेरिमेंट it can be said that the temperature is the manifestation or representative of the average kinetic energy of molecules. I repeat, sir, temperature is a representative, or temperature is the manifestation of average kinetic energy of molecules. If molecules have more kinetic energy, the temperature is more. Very good, sir. Now, let's see this in a systematic manner. अब देखिए सर, so therefore अभी मैं बताता हूं कि this component is responsible for the change in temperature, and I'll be showing you that with experiment this component is responsible for the phase change. Therefore, please understand, again I am telling you, a potential energy means intermolecular forces or bond energy that is responsible for phase change, and this is responsible for the temperature change. Okay, no problem at all. My dear students, one more point let me tell very clearly. Let us take solids. Let us take liquids. And let us take gases. In solids, it has the molecules are arranged in perfect order. Therefore there are strong forces. Strong forces I'll show by a thick line. Strong interatomic forces, or these forces are very strong. Intermolecular forces are very strong. And let us take liquid. A bit light एक लाइन से शो करूंगा है, लेकिन in liquid this is solid, this is liquid, and this is gases. So you know, my dear students, there are intermolecular forces, but they are weak compared to solids. That's why I have shown by thick lines. In gases, the intermolecular forces are negligible or na ke barabar or zero. So that's why they can move in any direction. Isliye, when you put a gas in a container, as there are no intermolecular forces or negligible, they take the they fill up the entire volume of the container. But unlike these liquids, you know, my dear students, liquids, they take the shape of the container, but at the same time, they do not fill, because still there are some intermolecular forces between the molecules of liquid. But solids, they have their own shape. Whether you put in that container or this container, they retain their shape because of the strong intermolecular forces. Okay, fine. Now, let me tell you, this bond energy is associated with what? Potential energy. Very good. Now, if you see, are there any intermolecular forces? No. That's why I say its potential energy is zero. Very good, sir. Now, are there any intermolecular forces? Yes. Yes. So, therefore, my dear students, it has a potential energy. That is, intermolecular forces are there, bond energy is there, it has that potential energy. Very good. Now, let me write. Let us say I am writing that energy as 100. मान लो 100 units. Yeah, minus क्या है, 100 क्या है, मैं बताता हूं सर. What does negative sign indicate? It means from my pocket I am supplying 100 units, so that when I supply these 100 units, जब मैं देखो, you have seen in like thermodynamics compression work, we take compression work as negative. What is the reason for taking negative compression work? The reason is, for compression, you have to supply from your pocket. That energy you need to supply. So when you are giving from your pocket, you are losing. Therefore, we take it as negative. It is just convention. Here also, when I am supplying heat, if that heat is going to break these bonds, suppose I need 100 units of heat. An example, illustration. It means from my pocket, I have to supply 100, so that from my pocket, I have to supply 100, so that all these bonds are broken. Now it becomes like this. तो इसके potential energy को zero बनाने के लिए, to make the potential energy of this equal to this, I have to supply 100 from my pocket. That's why, as I am supplying from my pocket, it is loss for me. Therefore, I am giving negative sign. So do not get confused with this minus. So therefore, this 100 indicates I need to supply. मतलब इसके पास इतना है, so that if I supply, these bonds are broken. Now it becomes like a gas. That's why I am using negative. For example, इधर आइए. Let us say now I am talking about this. I am talking about. अब ये दो ले लेंगे सर. अब ये दो ले लेंगे. For example, I say it is minus 50. What does minus 50 mean? It means you have to supply 50 units of energy to weaken the bonds and convert this solid to liquid. वेरी गुड सर। अगर हम इसको इसमें कन्वर्ट कर रहे हैं तो आई नीड 50 प्लस 100 150. So please note down that solids have the most negative potential energy. What is the physical meaning of this? Now I say it has 150 with respect to this. It has 100 with respect to this, or it has 50 with respect to this. What does it mean? It means I have to supply 50 units of energy to weaken these bonds and convert it into liquid. Similarly, I have to supply 100 to weaken these bonds and convert this into gas. Or directly solid to gas, I have to supply 100 plus 50, 150, so that all these bonds are broken and this gets converted into what? Gas. That is the meaning here. So gases have zero potential energy, but that doesn't mean कि like सुनो carefully, अगर algebraically हम compare करते हैं, negative is lesser value compared to zero. Algebraically, if I say this has less potential energy compared to this, and this has less compared to this, please आप कंफ्यूज मत होना. मोस्ट नेगेटिव मीन्स लेस वैल्यू. फिजिकली क्या है? मोस्ट नेगेटिव मीन्स आई हैव टू सप्लाई मोर सो दैट टू ब्रेक द बॉन्ड्स. Now, let me explain this in another manner. देखिए सर. Now, let us plot this. Now, on this, I am taking energy. ठीक है सर. Let us take solid. ध्यान से सुनो. यहां पे सॉलिड्स हैव द मोस्ट नेगेटिव एनर्जी. उसका मतलब उसका बॉन्ड इतना स्ट्रांग है तो मुझे उतना आई हैव टू सप्लाई दैट मच एनर्जी सो दैट टू वीकन द बॉन्ड्स. जस्ट नाउ आई गिव यू एग्जांपल. ओके, नाउ दिस इज लेट अस से लिक्विड and this is let us say gas, because gases have ये energy का है, gases have zero. This is actually showing the potential energy, not kinetic energy. This is showing the bond energy. For example, अभी बताता हूं सब, इधर देखना. Solid, liquid, this is gas. This gases have zero potential energy. Solids have more negative potential energy. This is showing the potential energy. बहुत बढ़िया सर, वेरी गुड. नाउ लेट अस टेक, बहुत केयरफुल देखो, एक काम करते हैं सर, लेट अस टेक -273 डिग्री सेंटीग्रेड और 0 केल्विन. जस्ट एन एग्जांपल. आई नो रीचिंग एब्सोल्यूट जीरो इज इम्पॉसिबल, लेकिन 273.15, चलो 0 केल्विन ले लेंगे, कोई बात नहीं सर. 273.15, चलो आप बहुत स्पेसिफिक है ना, 273.15, चलो कोई बात नहीं सर. ठीक है, let me take absolute zero, that is a -273.15 डिग्री सेंटीग्रेड और 0 केल्विन. ठीक है सर, बहुत बढ़िया. So you know at absolute zero there is no molecular momentum, the velocity is zero, the kinetic energy is zero. यहां पे kinetic energy zero. और एक बात, इस लाइन खींचूंगा मैं, let me write this as 0 डिग्री सेंटीग्रेड. So I am conducting all these experiments, say at atmospheric pressure, जो भी है, let this be the melting point, and this is the boiling point of water, which is 100 degree centigrade. Now this is BP. चलो कोई बात नहीं सर, देखो एक बार. Now you know my dear students, let's assume that I have, बहुत careful देखो, I have ice at absolute zero. Imagine Baba, ice at absolute zero. Can you tell me, when you have ice at absolute zero means 0 Kelvin. You know that temperature is a measure of average velocity. Absolute zero means zero temperature, means zero velocity. No molecular momentum exists at absolute zero. तो यहां पे kinetic energy is zero. But what energy it has? Molecules के पास क्या रहेंगे? At absolute zero, it has only, it is in solid form, ice at -273.15. So at absolute zero Kelvin, no kinetic energy. It has only मॉलिक्यूल्स का, इंटरमॉलिक्यूलर का बॉन्ड एनर्जी रहेगा, हाईएस्ट, मतलब नेगेटिव में हाईएस्ट. सो दिस इज द एनर्जी ऑफ दैट सॉलिड. मतलब यहां से इतना है सर. सो दिस मच इज द एनर्जी of that is the total internal energy is kinetic plus potential energy. So this is now, so if you take a solid that is ice at 0 Kelvin, which is absolute zero पे तो kinetic energy zero होगा, no molecular momentum, so zero line पे ये energy है. Now this is potential energy. Now slowly start heating. You know my dear students, when I start heating, From minus 273.15 degrees centigrade, slowly I start heating up to 0 degrees centigrade. What will happen? This ice will absorb heat, and that heat is used in creating random motion. अब लैटिस वाइब्रेशंस होंगे, मतलब सॉलिड में पूरा वाइब्रेशंस and that vibration energy or kinetic energy will increase. So slowly the kinetic energy will increase up to zero. Now this is showing the increase of kinetic energy. Now once it reaches this, अब देखो, this is the melting point. When it starts absorbing heat, now at that time there will not be any change in the kinetic energy. ये kinetic energy lane है, there will not be any change in kinetic energy. अब क्या होगा? Those bonds, solid bonds ice के, they start weakening. तो I am supplying, अब ये घटते जाएगा. So therefore slowly this, let us say it is 50. Now once it absorbs that 50, अब slowly bonds are broken. Those bonds are broken. Now that solid is converted into liquid. So इसीलिए you don't find any change in temperature. So whenever there is a phase change, it is representing change in the potential energy but not change in the temperature. So kinetic energy में कोई बदलाव, कोई change नहीं आएगा when there is a phase change. Now slowly when I am supplying, मेरे pocket से इतना गया, तो क्या हुआ? Bonds weak हो गए. So therefore now please my dear students understand, bonds weak हो गए, तो ये अब liquid solid में convert हो गया. Now liquid में solid, liquid has converted into solid. So if you see the energy at this state, now it पूरा solid liquid में convert हुआ. So therefore whatever the strong energy was there, bond energy was there with solids, that got reduced because I supplied. तो जो ये supply किए, so when you are supplying heat, that was going for phase change. मेरा solid ये potential energy changes के कारण liquid में convert हुआ, but that has not resulting in any change in temperature. So kinetic energy में कोई change नहीं आएगा. So now further you supply, क्या होगा सर? From this 0 degree up to 100. Now slowly the molecules absorb heat. So now the temperature will increase. इसमें कोई बदलाव नहीं आएगा. So temperature will increase. Kinetic energy is increasing. This is kinetic energy. Kinetic energy is increasing. Kinetic energy. Temperature has increased from 0 to 100. So this is the increase of kinetic energy. ये kinetic energy बढ़ गया सर, बढ़ने के बाद there will not be any change. Once it reaches 100, now the phase change temperature is reached. अब क्या होगा? Now at 100 degree centigrade my molecules start absorbing energy. इस अब ये stationary हो जाएगा, इसमें कोई change नहीं आएगा. My molecules start absorbing energy. Now these bonds will become weak. So what will happen? At 100 degree centigrade when I start supplying heat, no, it doesn't result in random motion. It results in weakening the bond. देखो एक बार. So from this it results in weakening the bond. So यहाँ तक when I supply up to from liquid to gas, let us say it is 100. From there, what will happen? It absorbs. All the bonds are broken. When all the bonds are broken, no change in the kinetic energy, so no change in temperature. So at a constant temperature, the potential energy is changing, and thereby the phase change is occurring. Now, finally, this will, once I supply complete amount of heat, once all the liquid is converted into gas, now there is no bond. All the bonds are broken. When all the bonds are broken, still you supply heat. अब बचा क्या है सर? There is no phase above gas. अब क्या करेगा? Now once these bonds are broken, ये liquid है. देखो ये liquid के bonds जब break हो गए, so now it is gas. So from now on when you supply heat, this no bonds, now therefore they move randomly, so the kinetic energy increases and thereby again the temperature increases. So ये kinetic energy बढ़ रहा है, इसका मतलब temperature 100 से 110 कोई no, there is no potential energy. Already gaseous state में reach होगा. For gaseous state the potential energy is zero. Therefore now from here on it will result entirely, when you supplying it, entirely it will result in change in temperature but no change in the phase, because all phase complete हो गया. So with this I'll give you मतलब एक छोटा अच्छा illustration बताऊंगा so that you will get some idea. एक second. Just see this. Let me demonstrate this practically. This is one molecule, and please see the interatomic forces. Now, When you are supplying heat, let us assume that the system has the reached the phase change temperature. For example, if it is water, so say it has reached 100 degrees centigrade. Now, once I start supplying heat from 100 degrees centigrade, it is not going to cause any motion, but that is going to break these bonds. For example, now I'm supplying heat continuously. Let me supply. So when I supply heat continuously, I will just say this bond is now I'm supplying continuously. I'm supplying continuously. Yes, the bond is broken. Now, once it reaches 100 degrees and once bonds are broken, now there is a random motion. Now, further, once you cross 100, the velocity increases, kinetic energy increases, and again the temperature increases. So, during phase change, whatever heat you are supplying, that is going to break these bonds. Therefore, there will be change in potential energy during phase change, but no change in kinetic energy. Once the phase has changed, now there is a huge change in velocities, there will be change in temperature. Okay, let's continue. Chalo. This person has taught very nicely ना, very good. Now great. So observe here. तो यहां से बहुत क्लैरिटी से बताऊंगा सर. Total internal energy has two components: kinetic energy, potential energy. Potential energy means atomic bonding and intermolecular forces related energy. So this kinetic energy deals with temperature. This potential energy deals with phase change. Once it is, say for example, once it is -4 to 0 degree centigrade, let's take ice, -4 to 0 degree centigrade, it has not reached the melting point. So -4 to 0, kinetic energy will come into picture because temperature is changing. No change in the bond, potential energy. Once it reaches 0 degree centigrade, you still supply heat, those bonds become weakened, and thereby that energy, whatever you are supplying, is not going for kinetic energy, but it is going for potential energy. Very good. From once it gets converted to liquid, from 0 to 100, it gets, now the temperature is increasing, kinetic energy is increasing. So once you cross 100, so once you touch 100, that at 100, when you are supplying heat, that heat is used in change in potential energy, breaking the bonds. No change in temperature. Once that complete once complete bonds are broken, from there on, whatever heat you supply, they are in random motion, the kinetic energy will increase. So this is very, very important. And one more thing you need to observe is, my dear students, so take specific heat. You know, specific heat is the ability of the medium to absorb energy for a unit rising temperature or to store the energy. So specific heat of steam or ice is roughly in between 2 to 2.1 kilojoule per kg per Kelvin. For steam or ice, it is in between this. And for water, it is about 4.2 kilojoule per kg per Kelvin. It means the same material, the same substance, the same pure substance has different properties in different phase. That is to be noted. Okay, if you have understood this, kindly share your views in the form of comments. Thank you. I'll come up with many more such videos. Thank you. God bless you.